Okay. Hello, welcome to day 5 of this bootcamp. And this is the last day when it comes to the explanation, at least. There will be a competition for the next 2 days, which I will announce the details for later after we finish today's session. So stay tuned. So today we'll be learning how to use YOLO, which is a framework, a library for object detection. YOLO is short for you only look once. So the idea is that it's very light and can be used on something that's not on hardware that doesn't have a strong GPU or CPU, and it's very fast. Um, yeah, and it's also very easy to use. Um, that's why you can see like a lot of people are using YOLO for object detection in general. Okay, so let's start. The first thing that we have to do before we start training our object detection model is to prepare the data set. So these are the images of the packages that I sent you before. And the first thing we have to do is to label these images. In order to do this, we will be using this website called RoboFlow. So this website is a website that helps you to label or annotate the data, and then later will also help you to maybe deploy your model. So this is like the landing page. Once you go into their website, this is what you see. And let's sign in. Okay. So if it's your first time signing in, you won't have this. It will ask you like to create a new project, or you'll have like the default project. But just ignore this. Just create a new project anyway. And we will choose object detection. And let's call our project package detect. Okay. Based on the images we have, we can like detect the packages or the parcels. And we will be detecting package. This is like the class name. You don't have to define them here, but just, why not? So let's create this public project. And the first thing that we have to do is to upload the images. So I'll upload the images that I sent you previously. Just drag them and drop. And you can see that they all appear here. So let's save and continue. Okay. The next thing that we have to do is to label, as I mentioned. So if you have like a large data set, maybe you'll need someone else to help you to do the labeling. So you can invite someone to help you annotate. But for now, it's only 26 images, so I'll just do it myself. So I'll assign myself to do these labels. And once you have this screen, you can just start annotating. Okay. So this is the RoboFlow like annotation uh, like view. You can zoom in and so on. And all you have to do is just press on your mouse and then drag to annotate. We need to do this for all the images because that's how the model will know whether it's right or wrong. So we'll try to guess where the box should be and then compare this box to this box that we just drew. And we can see, yeah, that this class is package. So we'll just save that. And to make this faster, you can press on the right arrow key and it will automatically like get the next image. So you don't have to keep pressing these arrows. And you can just annotate, press enter, next, and so on. And you should always try to make sure that the box that you're drawing like doesn't contain something extra, like as small as possible. You can always make adjustments, which is nice. You can just make this smaller. And the dimensions are important because if you include something else then later on the model might learn that this background is part of the object, and we don't want that. So just label all the boxes, enter next, so on. We only have 26 images, but then I'll show you why RoboFlow is very nice, because we will turn these 26 images to like 62 or something, 62 images using augmentations. But ideally, you should have like, if you're training a model, you should have at least 100 images. And then using RoboFlow, maybe you can like augment these images to 300 or something, which should be enough to train like a decent model. But for now, 26 is enough for this tutorial. Otherwise, this will just be 2 hours of me labeling. Okay. Any questions regarding this while I'm labeling? Meanwhile, you should like go into RoboFlow and create your account or sign in if you have not already, and try doing the same. Create a project and then go into upload the images and start maybe labeling if you want to. You can see that these guideline rulers are helpful because I can align like the edges that I want. Like this now is aligned with this edge, and then I can make sure that this align with this edge too, and then I can just start the box, which is nice. And generally for object detection, choosing your data set is very important. You should take images like from all different angles. You can see this guy took pictures of the parcels like through his window, which is very useful for the model to see like different scenarios where this object might be like located. And also the lighting might be different and so on. So it's always useful to take pictures from all different angles and so on. The larger the data set you have, the better the model will be, especially if like the data set is like from different parcels and so on, or different types of objects. It's even through this flower thingy. Okay, so we don't want to include the flowers also, so we just make this smaller. Okay, this one too. Can edit this one. No, no one draw. Can click on them, click on this one. Then maybe move this a bit smaller. Kind of, we want to decrease the amount of flowers that there is in this frame as possible. The drag tool is what I just used, and normally we're using the bounding box tool. Okay. Nice. So we're done. I've annotated all the images. So you can see unannotated or 0, and everything is annotated. You can see the preview of all the images here. So once we've annotated the images, we can add these images to the dataset that we have. And this split is important because we want some images to be used to train the model, some images be used to like validate whether this model, like the accuracy of this model and so on, and then 10% to test this model's accuracy. So this split is common, but you can change it. Like you can decrease the amount of tests and so on, but we can just leave it at the default settings for now. So let's add these images. And you can see that this is the data set that we just created. And these are the images inside this data set. Okay. And they're labeled either validation, training, test, and so on. The next step that we will do is generate a data set using the images that we have, but we will do some pre-processing and some augmentation. So the pre-processing is stuff like this, resizing all the images to 640 by 640, which is the input to the YOLO model. So they are all the same standard size. You can see this is the original, this is the resized. And auto orientation is like, it makes it all look at the same angle or rotation, just to standardize. So yeah, you can add more processing steps. You can make it grayscale. You can like crop some stuff and isolate the object only, remove the rest of the image, and so on. But no need for that. And then augmentation. This step is important because it will allow us to create like more of our data set. So the classic ones are flip, and you like apply horizontal flip. So you'll have this door and then the door flip to the other side. And it will also flip the bounding box, so you don't have to relabel something or re-annotate. It will just take care of this. This is why RoboFlow is just so nice, so easy to use. And we can also add rotation, rotates the image a bit, also useful. 15 degrees is nice. You can see rotates it -15 and +15 too. And let's also add some noise. It adds some noise across the image. Let's decrease this a bit. Don't need so much noise. So yeah, makes it a bit noisy. And then let's add some brightness. So this will like increase the brightness a bit and also decrease the brightness a bit for some images. So the model can learn that the lighting doesn't matter. Don't relate the object to the lighting at all. Okay. So yeah, that should be enough. And then it will ask you like the maximum size. So we will select 62. We will generate 62. If you pay for RoboFlow, you can have up to like 908, which is like 50 times. Like imagine you just label 26 images and you get like 908 images as a data set. It's like, damn. Well, let's just stick to 62 for now. Oops. So yeah, then we just click on generate. And this will generate our data set. Nice. So this is the output, the 62 total images. 54 of them are training, 5 for validation, and 3 for testing. These are the pre-processing and augmentations applied. And you can view all the images here. You can see some are rotated with noise, darkened. Yeah. So that's nice. We get like a boost in our image quantity. So let's go back to divergence. And now that we have the model, we want to download now that we have the data set, we want to download this. So you can train on RoboFlow, but it costs like these credits. So we don't want to do that. We'll just train using YOLO locally. So we'll select custom train and upload. And we will select YOLO version 8, which we'll be using. So get snippet, and it will give you like the code that you should use to download this data set. So we'll just copy this, and let's go to our VS Code and get this data set. So let's go to this file, which is the file that I sent you. And we'll create, say, train.py. We paste the code that they gave us. We don't need to install RoboFlow. I already told you guys to do that. And this is the API key, which should be hidden, but don't worry, this is a throwaway account. I'm not be using this account after this at all, but you should usually hide your API key. You shouldn't show this. Okay. And you can see this is the project that we have created, the package detector, and then some uh, unique string. This is bootcamp, which is like the workspace that I have. And then this is the download option. This gets the dataset and then stores it in this dataset object. So if we run this, it will just create a new folder here, and it will call it packages, I think, or just package. Okay, so we have packages detector one here. This is the data set that we just generated with all the test images and stuff, and including the labels. So it's as easy as this. We have the images that we want in the YOLO format, and we also increased their number from 26 to 62, which is very nice. And now we can actually start the training. So any questions about the steps from like a normal image, normal folder of images to this folder, which has like this train validation and then this YAML file, which we'll be using to pass this dataset to the YOLO model to train. Okay, I will show on RoboFlow a bit slower. So after you annotate, you get this data set. Okay, so I currently don't have any images. Never mind. After it's done annotating, it will ask you to like add this to the data set, add these images to the data set. So you press this, you press add these images to the data set, and then you'll just have the images, the 26 images laying in this data set. So you go to generate, which is here. It will ask you to generate the new data set, and these will just keep at the default. For augmentation, we'll add these 4 augmentations: flip, horizontal, rotation, brightness, and noise. You can add more. You can try adding more. You can try adding blur. You can crop parts of the image and so on. You can play around with this. You don't have to follow the same augmentation that I used. And then yeah, select 3 times and generate. Once you have generated, it will appear here as versions. And then you can train with RoboFlow. I only have 3 times that you can do that. So it's better to train locally. You will select the model, which is YOLO V8, and then press on Get Snippet. This is the snippet that we will paste there. It has the API key here, but it's hidden here. But when you paste it, when you copy it and paste it somewhere, the API key is visible. So yeah, this is how you get the API key. And that's all. After this, you just run the code that they showed just now, copy it, and then you paste it and run this, which is this code. Okay. Nice. Okay. Let me know if you want me to repeat this. I feel like, yeah, I also went too fast the second time. Okay. So this, after we get this code, after we run this, we get the dataset download here locally. And what we're interested in is this data.yaml file, which will tell the YOLO model where to find the images. The test images are here, train and validation and so on. I want you to change this to dot and then the thing, because they include package detector for some reason, and that is not okay. Change these all to dot /. Okay, because they're all in the same file. The train and validation all in the same file as data.yam. Once you've done this, we'll go back here and we'll actually start using the YOLO model. So let's keep this. And from Ultralytics, which you should have already installed, import YOLO. You only look once. Okay. The first thing we will do is define our model. And this will be as easy as saying YOLO, and then see they have default models. One of them is this YOLO v8n.vt. This is a default model. They have N, they have S, M, L, and X. And they stands for like these sizes. Okay, this is the Ultralytics official documentation. And this is the one that we're using, 8N. But there's like 8 uh, S, M, L, and so on, depending on the size of the model. Then if you go here, models, V8. Okay, yep, N, S, M, L, and X. The more you go, like the higher you go, the more accurate you'll be, but the you will suffer in the like GPU area, or the processing power required is more, but it will be more accurate. So for now, we'll just use 8N, but in the future, you can use the heavier models, but just keep in mind that we'll need also a good laptop or something that has a GPU to run these. Okay, I think S should be fine as well, but starting from M till X, you need to use a GPU. Okay, so for now we'll just do 8N PT. And this is like, they have this model, so we don't have to download this. Once we run this, it will automatically download this into our directory. Okay. Okay. Next, we'll have to do the training. It's as simple as model.train. And then we'll give it the path to the data. Okay. So we want to give the path to the .yaml file inside here. So we'll just copy the path, right click, copy path, and then paste it here. And then we add one more slash and say data dot. Yeah, this is where it will get its data. And then we have to define the number of epochs, which is like how many times it will go through the entire data set to train the model. So let's set this to 50. I think 50 should be okay. Normally you would want to train this for more than 50. 50 is not enough. But let's just train for 50 now to see the result. And yeah, that should be all. Model to train. I will train the model. It will save it automatically inside a file that it will create now. And all you have to do is watch at this point. Okay, so let's run this. It's downloading the YOLO. Yeah, it's here, YOLO v8n. And then it started training. It's getting the labels, so on, first epoch. And you can find there's a file called runs. This will have the training data. And inside there is the text, because we're using object detection. Then train. These are some like results already. It will keep outputting the results, you can see. And these are example images of what it's doing now, the results that it already has. Train batch 2, train batch 3, you can see. This is a label. It's called a corologram, which just shows like the X and Y of the box and the width and the height. There's nothing important. Once it is done, I'll show you the important stuff. But these are the stuff that you can see like while it's training. And inside the weights folder, this is the best and last models. So it stores two models, the best one, the best performing one in terms of accuracy, the minimum loss, and then the last one during the training. Okay, so this is all included inside the runs folder. So for now, we just have to wait until it's done. It's already done, I think 3 or something, 5 epochs. You'll see now. Any questions so far? 5 done. I can repeat the RoboFlow part if someone wants while it's training. There's not much to do while it's actually training. It's not working. Which part? The training or the RoboFlow part? Okay, syntax error. Can you go to escape, buddy? Okay, did escape. Try switching all the backslashes to forward slashes. Maybe that's the problem. Might be. It's a Unicode error. I'm assuming it's something to do with the path itself. Let me search for this Unicode error. Yeah, I think use forward slashes and it should be okay, according to Stack Overflow at least. Try. Okay. Yeah, sure. For the RoboFlow part, which is here, let me just repeat everything, create another project and show you. So this is the project that we are using now. So if I create another project, object detection, and then we'll call it the same thing for now, package detector 1, and we will be detecting packages. That's great. Now we have to provide the images. So I'll just drag the images, drop them here, and then press on save and continue. You can select who's annotating and then what amount of images to annotate. Just assign everything to ourselves. Okay. It seems like it detected that these images are already there. So auto annotate. Okay, work now. Nice. And then while annotating, you just get the bounding box and then draw. If you want to adjust, you can press on this drag tool. Then you can adjust a bit. Okay. Once you're done annotating all the images, you just add them to the data set and then decide like how much you want the split to be. This is the usual standard, but you can decrease if you want more training data, less validation, and so on. Let's just add these images. So now you get a data set that has all these images, the 26 images that we annotated. And then you press generate. This generate. These will keep the same, just stretching and resizing the image. And then for augmentation, you can add flip, select horizontal flip to flip the image to the other side. You can add the brightness one, which is like brightens and darkens the image. You can add, let's say the rotation, 15%, 15 degrees, like forward and backwards. And finally, I guess you can add the noise and then reduce it somehow because this is too noisy. 1% is okay. You can continue adding stuff. You can crop the images a bit, add some cropped images, but you might lose some of the bounding boxes. So like, yeah, be careful. Can do a lot of stuff. You can blur it a bit so it like detects if it's blurry. Apply all you want. And then here, select how many times the size of the data set you want to be. We'll select 3 times. If you want to pay for this RoboFlow or if a company is paying for you to use this, you can go up to 50 times the amount of images you have. And then you just press on generate. It generates the data set. You can see the images and stuff. And then you press on custom train and upload. Select the model, which is YOLO V8 that we're using, and then get the snippet. So it'll give you the snippet to use to download this data set. You just copy this and then you run it locally. You get the dataset file, the dataset folder, and that's all. That's all we have to do for RoboFlow for now. For now, later we'll use the deploy function to deploy it and show you why this is useful. Yeah. Anything else? Okay, nice. Let's see. The training is now 25 out of 50. Still have to wait a bit. Let me see what else I can show you. I guess we can talk about the deployment. So deploying is like, once we have trained the model, you can upload this model to RoboFlow. And then once you do this, you can use this uploaded model to do detections on other platforms, not just Python, and you won't be running the inference locally. It will be running on the server. So after RoboFlow, after you get the data set, you paste it here, you download everything. So your code will be like this for RoboFlow, something like this. Run this, you will get the packages detector or whatever you call the project, which has all the images. Once you have this, you can import YOLO, define the nano model, and then train it and pass the data as the absolute path to your packages detector. You can get this path by right-clicking and then copy path, and then you just paste it here and add the data.yaml. We want the YAML file, which is here. And then you define the number of epochs, which is for us will be 50. That's all. If you want to train more, let's say you train the model, but you want to retrain it and like increase epochs for any reason, you can pass something called resume equals true. So resume, and then you have to pass here instead of this default model, we'll pass the model inside our runs, which is waits here. We'll pass either the best or last. So we'll have also copy this absolute path, put it here, and then you can use it. Okay. So you will give it the last maybe wait, then say resume equals true, and it will like do more epochs for the same model. So you don't have to worry if I now control C and it stops at like 32 epochs, I can continue by doing this. Okay. Nice. Once you run this, you'll just start training. Oh, there was an error. What was the error? The error message is too big. Damn. Oh, okay. Send on WhatsApp. Sure. Yeah, it does affect. Right now I'm running on CPU, so it depends on your CPU. You can see that the GPU memory is zero, not using anything. If you wanted to use the GPU, you need to install the NVIDIA drivers for this and so on. You can do this, and it will train much faster on a GPU than a CPU. But the idea is YOLO is lightweight enough to train on a CPU and to use on a CPU and get like a decent frame rate. I think if you have like i5, i7, maybe even i3, you should still be fine if you want to install the drivers. And they have, I think, slightly different commands if you want to use. Let's go back to this one. I think you just specify the device. So train. Okay, this is single GPU or CPU training. If a GPU is available, then it will be used. They mean if there is like if you have the drivers for this. Otherwise, it will just use the CPU. And then you can use like multiple GPUs. You can specify the device, like use the CPU and the GPU, depending on what you want to do, and so on. If you have a Mac computer, there's something specific for like the chips for some reason. Yeah. Okay. There is a Unicode. Oh yeah, this one, yeah, just change all, yeah, replace all the slashes with forward slashes. Okay, let me see this error. And then that is a huge error. Okay, it seems like it's trying to say that the path is not correct. Yeah, this should be fine. So it's like trying to add something to the path. You can update this in settings.yaml. Okay, let me show you because they have a very stupid settings.yaml. So if we go here, I just created another terminal and type YOLO settings. It will give you some settings inside a folder somewhere on your computer with like dataset locations like this one. So it seems to me that it's trying to find the data set inside this file or like using this path. So you can try pressing on this control and click, which is the settings.yaml, and changing this to the current folder. This might solve this huge error that you have. Try and see. Just change it to like the general YOLO V8, or like whatever folder you have the name here, and then do the relative path here, just dot slash and then package detector data.yaml. Try this. Oh, YOLO is not even recognized. What? Maybe try adding YOLO to the environment variables, or just go, if you're using Windows, just go to this path, like users, and then your user, app data, roaming, ultralytics, and then settings.yaml. Follow this path, this one. And then inside, change the dataset directory. What slashes do we replace? Replace the backslashes with forward slashes or with double backslashes. Should, should work also. So instead of this, you can do this, like two of them for each. Or you can do forward slashes, which is like this, like this. Okay, try if this doesn't work. Yeah, I don't know why it doesn't recognize YOLO. It might be like an environment variables thing. You need to add like try Python M YOLO, like Python M YOLO settings, something like this. Try this and see if it works. Because I think I don't know if you can you type pip install something, or it will also say that this doesn't exist. Okay, the training is done. Okay, so is it fine? Did you find the file? Try. I want everyone to at least reach the part where they're successfully training before we move on. No module name YOLO. Okay, never mind. You don't need to use YOLO anyway. Just go to the path, to this path. See users and then your user, app data, roaming, ultralytics, and then settings.yaml. Manually go to this path on your computer. Permission denied. See users, desktop, day 5, package. Permission denied. Try running VS Code as permission to the path. This is the path here. Or here also. Yep. For Abdullah, try running VS Code as administrator. Seems like cannot access some files. Permission denied, I guess. Or maybe I guess you can change this to just data set. So data set. So you don't have to keep changing this. So it will be relative to your local environment. So you just create a new folder you call datasets, and then you put the package detector inside. Same as this waits and runs stuff. Can fix the error. Which one? Oh, why? You can find the. Oh, no. My cat is interrupting. Wait a minute. Okay. Did you find the folder at least? The ultralytics and then settings? And for Abdullah's error, permission denied. It still says permission denied. Kind of find. Is this path that you sent the actual path where the thing is? That okay. Yes. And it still says permission denied. It doesn't. Okay. I'm not sure why the permission is denied. Let me search on Stack Overflow, see if someone has faced the same issue. Share. What about the others? The others are able to run. That's okay. They can train. Oh, what is this? Okay. Oh, this is the same error. Permission denied. Check data set. Permission error. Error number 50. Tr- Try to replace if you have only one like quotation. Try to replace it with two. Like if you have this, replace it with this. Might solve the permission denied stuff. Yeah, yeah, I saw. I saw the error. Try replacing these two quotations with one and see if it works. Okay. What about the wrist? Is anyone else having the same problem? Or everyone else is able to train their model, or at least begin the training? Just fully. Okay, sure. Maybe you're like misspelling package. Like, are you sure that you spelled like the file's name package is spelled like this? Or just double check the path in case something is like the spelling is wrong. And it should also contain like shouldn't end here. It should also contain the data.yaml. I'm not sure if you do did that already or not. But you should have the data.yaml. Okay. Not just the path to the thing. Okay. Okay. How about Ahmed? Did you get like you solved the problem? Did you change the settings.yaml? Did you find this file? Okay, never mind. We'll continue for now. If you oh, there's no ultralytics in roaming. Oh damn, that's weird. If you installed it, then it should have created the folder here. Never mind. You can try maybe uninstalling and installing again. Maybe. Maybe it just didn't create the first time. Okay. Anyway, after the model is done, yeah, VS Code is playing games for real. Okay. After the model is done training, so we have trained for like 50 epochs, we can evaluate the results. There's results.png, and this has like the training. This one is the box loss, which is like how far away the box that they draw from the actual boxes that we annotated. And then you have the class loss, which is if you have multiple classes, and we just have packages. So it's comparing like did something detect the other thing, like the draw that this was a package, but it was a cat, for example, or something else. This is the class loss, and so on. There's precision for the validation. There's also box loss and class loss. The validation is important because it's not the same images that it's using for the training. So you can see these are different, drastically different, which is not ideal. Ideally, you don't want this. You want this also to be like a downward curve like this. So maybe you need to train more. For the class loss, it's okay. It's also at like a downward curve. So that should be fine. You can see from the patches also, like these are some of the detections, which look pretty nice. This is the validation. Also looks okay. So, okay. And we have a model. There's other stuff if you want. I'm not sure exactly who uses this and for what. And there's something else. There's the confusion matrix, which is like how much does it detect? If you have more classes also, you can see that this is actually package. This is the truth. And then this is the predicted. So when the truth was that it is a package, it's 90% of the time it detected that this was a package. 10% of the time it detected the background instead. And then same the background, instead of detecting the background 100% of the time, it detected the background as a package also. So this is not good. Ideally for this, you want like a diagonal shape. You want like for each the package, at the packages, 100 or something high, then so on. But we just trained for 50 epochs, so it's fine. And so yeah, this is the same as this. So yeah, that's all for like the data that you can look at to determine whether the model is okay or not. The next thing you might want to do is actually use the model. Okay. And maybe I'll send the model that I have, like this runs file, to the WhatsApp group. So if anyone that didn't manage to train can use this step, let me do that just now. Okay, so I sent this on the group, and if you didn't manage to train, you can use this file, but you need to change the path uh, inside this arguments. But I think this is only important for the training, so never mind, don't bother. Unless you're gonna retrain or resume training, this doesn't matter. Okay, so let's close the other stuff. So now we have a model. Now we will use this model to detect. The first thing we want to do is import our classic library, CV2. This guy, OpenCV, used everywhere. We don't need the training. And for this, we will pass instead the model path that we have, which is, let's just copy double quotations and copy here to the weights, copy the path to weights, pop it right in, and let's select the best performing model. Once this is done, we can maybe import an image and try. Let's import this package image. So say that image equals v2 dot image read, and then we read package jpg. Okay, and now all we have to do is detect using this image. So say results is equal to model, then directly pass the image. That's all we have to do. Okay, it's very easy. Using YOLO is very easy and simple, which is why a lot of people use it. So once you do this, once you use the model to get the results, there are multiple ways that you can display this on the image, this result on the image. And you can say the first way, the easiest way, the way that they already provide is saying the image, for example, is equal to results, and make sure to select the zero index of results, because this you can pass like multiple images, like you can do a list, can pass multiple images, so the results are always an array. So in this case, we know that it's always going to be the first result because we're only passing one image. And then there's a function called plot. So they already have a function to plot everything inside the results. So that's very nice. So you get this new image, let's say prediction image. Prediction image is equal to plotting the results. Okay. And then all we have to do is show this image. So we do the time show, and then we show the prediction image. We also have to add weight key, and since it's one image, we'll just do 0. So weight key 0. So yeah, that's all. As simple as that. Let's see. This works. Oh, okay. So this I'll change to forwards because it seems like it does not like that. Okay. Prediction image. Oh, sorry. This I should also include the name of this, which is, let's say, prediction. Okay. So we have our image, our abnormally sized image. And we can see that it detected this package, detected like a very long box. The entire thing is a package. Detected also these two as one package. It's not very accurate, as you can see. Okay. Uh, One thing we can do is before we pass this image to the model is to resize this image because the model is expecting the image to be 640 by 640. So let's resize this image to 640 by 640. Interpolation is equal to CV2 dot enter area. So let's try this. Okay. You can see that performance is a little bit better. Sees this as 0.7, the middle one as 0.52. It didn't detect the lower one, but we can change this by setting the minimum confidence. So we can pass to this model, other than the image, confidence, which is conf, then equal to, let's say, 0.3, just 0.3, or maybe even 0.2. Why not? Let's see how many false detections we can get. Okay, so it still only sees these two. Maybe with more training we can, or maybe if we add this image to the training data set and then label this, then it will be able to get it correctly. But yeah, that's it. We have a working model that we just trained using the images and everything. No, there's no limit. You can train as much as you want, but at some point, the training is kind of useless. Like it reaches a point that it just becomes flat. There's no changes. So if you want to improve the performance, you either need to add more images at different angles, see exactly like where it makes mistakes and then correct them. Let's say it detects like human faces as packages. So you get pictures of people holding packages and you only annotate or label the packages. This way the model knows, oh, so faces are not packages, and so on. Okay. Nice. I want to show you how to get the actual like coordinates of the boxes because usually if you do something like this, you want to like find where the box is on the screen, the X and Y coordinates. Um, so this, you can do this by simply, let's say you want for result, or let's say for box, directly for boxes, and results 0, just the initial result for each box or box in boxes, because each result will have maybe 2 or 3 boxes like we just saw. And then for each one box of these, we will get the points, call it, let's say, box xy is equal to box dot xy and the zeroth index. So they already have a function inside their boxes that returns xy. They also have a function that returns xy with height. So both are useful. Xy is like top left corner and then bottom right corner, like you would draw it using OpenCV. You can also get this one with height, which is xy of the initial point, and then the width and the height of the box, and so on. And the reason this also has zero, because it is like an array inside an array. So this will have like 4 values, xy. And if we remove this, it will be like an array. And then inside this array, there's another array with xy for no reason, but just know that. You need to add this 0th index here. And something else you can get is the confidence, which is just box.confidence. And you can also get the class, which is like a package or cat or whatever the name is of the class, by saying box.class. So this is how you would get the data that from the results. But just to plot, you can just use this plot function. And you can pass a lot of stuff to this plot function. You can change the color, you can change whether you want the confidence to appear or just the name, and so on. If you want the settings for this, you can find it here. If I go to predict, and go to, there's a predict results object, which has the plot function also. If I go down, this is the boxes. You can see the boxes documentation. Let's see the results documentation. So, yep, this is the plot function. And you can choose whether confidence, true or false, which is whether to plot the confidence score. You can choose the line width of the rectangle, the font size, the font. You can, like, it has already a lot of utilities that you can use. If you don't want to use this for any reason, you can just draw it using CV, OpenCV, because you already have the XY dimension of the boxes, and then type the class. You can say put text also, the class above the box, and so on. So yeah. Everything okay so far? Any questions? Okay. If no questions, the next thing we want to try this model on is a video. So we want to apply this to the frames of a video. So it'll be the same thing we did for OpenCV. Okay. So the first thing we do is define the capture. cVideo.video capture. And then the thing is called packages.mp4, the video. Okay, once we get this, say while capture is opened, and then we don't need this. Also this. Okay. All right, it's open. The first thing we want is the frame itself. It's equal to get.read. Then we will pass this frame to the model. And then this predicted image we will get from the results. Display the image. Then let's add the condition here. This to 1 is equal to the unique code of Q. Then we will break. Yeah, that's all. As easy as that. I did not forget anything, that is. Let's see. So this is just a video of packages. And you can see that it's able to kind of detect some packages. Here a little bit, detected this for a sec. Yeah, this one also for a second. So yeah, that's it running on a video. And you can see that it's pretty fast. It's not slow or anything. And the next thing I want to show you is to actually get the frame rate, the FPS of this, and display this FPS. So let's quit this for now. First thing we want to do is import time times the Python standard library for accessing time. And then first thing we want is to define something called previous time, and then that is equal to the current time. Okay. And then for each loop, we will say that the FPS is equal to 1 over the time now minus the previous time. No, not the prediction image, the previous time. Okay. Because if we get this is the time between the frames, time minus previous time. This is in time, and FPS is a rate, is a frequency. So we just 1 over this, we get the frequency, the FPS. Yeah. And don't forget to set the previous time now to the current time. And then we will display this using cv2 to output text. Put this on the top corner of the screen on the prediction image. And then we will add string, let's say FPS, and plus string FPS. And let's round this to the nearest 2 decimal points. Next. Okay. So it's done. Oh. Okay, here. The next thing is the origin point. Let's say 4040. The font phase is font Hershey complex. 1 is the font scale. The color, let's say, is green. Thickness is 2. Yeah, and that's all we have to do for the FPS calculation. So now we can get the FPS count on the screen. Okay. So now you can see the FPS is like 12 FPS, 13, 12, 13, something like this. When I was running before using Zoom, because Zoom is also sharing the screen, taking some of the CPU power, and reach about 15, 16 FPS, which is nice for something running purely on CPU, no GPU. So yeah. Any questions about this? Okay, it finished and then began random stuff. Stop. Okay. Any questions on this? You can also do the same. Put this as 0 and then use your webcam, then detect, bring parcels and see if it detects, and probably detect your face also as a package, just in case, just a warning. Any questions about this? I will send this code to. This is no longer trained by this, like train and detect and do everything. Okay. Any questions about the entire thing in general? RoboFlow, training, and so on. The last thing we want to do is deploy this model to RoboFlow, and that should be all. Then we will be done. Okay, so the thing is, now we have a model that runs locally. But let's say you want to run this model on a small device. something that doesn't have a lot of processing power. Or you want to run this model on a website or on something else, anything really. So you want a server running this model, and you just want to send this server an image, then it will send you back the results. So this is what RoboFlow does essentially. So we will use RoboFlow. We will ask RoboFlow to host our model for us, and then we can later send it images and then receive the results. So I'll comment for now all the code for the YOLO and then go back to the RoboFlow code. We need this RoboFlow object and the project object, which has like our details. And then what we'll do is say project version 1, similar to the download argument, but instead we will say deploy, and then we have two things to pass. The first thing is the type of the model, which is YOLO V8, and the second thing is the path to the model. So the path to the model is inside our runs directory, and then I think we can just give it train, and then it will do the rest. So I'll just get this path, change these to double. Okay. And that should be enough. It will know from train, like, oh, okay, I'll go inside weights and get the best and the last and so on. And with this, we can run the code and deploy this on RoboFlow. It will ask you like that RoboFlow is using this type of ultralytics, but you have this type. Do you still want to continue anyway? Yes, no one cares. It's almost the same type, version 8 anyway. Done. The model was deployed. So let's go back to our overflow here. And if we like go back to deploy, oh wait, this is the wrong project. This one is the original one. If you go to our deploy tab, you'll see that now it's loading because we have sent the model to RoboFlow, and we can actually do some detections over here too. I'll show you just now if it loads. It's taking some time because it's like uploading the model and maybe trying the model a couple times. So we'll try to detect this parcel now. You can see 91% can have the predictions in like a JSON format. And they give you like examples. If you want to use it on Python, this is how you use it. It will return a JSON file. JavaScript, Swift on iOS, .NET if you're using C# or anything else. Even curl if you're like on Linux. It's very useful when you deploy this. And they have examples for a web application. They have examples if you want to use it with video, like we just did. You can deploy it to a Jetson, NVIDIA Jetson, whether it's Nano, Savior, whatever. They also show you how to deploy it on iOS. It's very useful. Raspberry Pi, also they support Raspberry Pi. All of these devices, they are able to run the model locally, Raspberry Pi or NVIDIA Jetson. But if you run it using RoboFlow, it will like take less computing power. So it doesn't use that much computing power because all the computing will be done on their servers and you just get the final image. So you can upload stuff here also. You can upload an image or a video and stuff, or you can use your webcam, test the model. You can play around with the model here, adjust the threshold. You can choose other images. I will try to detect. So yeah, overall, RoboFlow is very useful. Whether you're using YOLO or TensorFlow or anything. So yeah, this sounds sponsored, but no. I mean, I would be glad if they sponsor me, but you know. Any question? Does anyone have any question about the entire process from the start, like getting the images, labeling them, downloading the dataset, training, and so on? For the people that have like issues, some errors, maybe they can text me later, then I'll try to solve the errors that they have. Otherwise, if no questions, we can go ahead and explain the competition for the next 2 days. Why not use Google Colab? You can use Google Colab to train specifically. Training on Google Colab would be nice. Yeah. Otherwise, I don't see any need to use Google Colab. For training, you can use it since you'll be using like Google servers and stuff to train. Maybe it will be faster than using your own CPU. But otherwise, yeah, nothing else in this process requires Google Colab really. And I prefer to do stuff like locally instead of Google Colab. But you can you can try Google Colab for sure. It wouldn't be any different, almost the same, everything the same. Okay, nice. Since there are no questions, I guess I can move on to the competition explanation. Okay, let's go back to here. Present. Okay, so for the next 2 days, you can join this competition. And the idea behind the competition is I won't tell you like a specific project to do, but there are criteria to the submission. So you can do any project that you want to do using the knowledge that you've gained throughout the past 5 days. And we will grade those based on the creativity of this project. So if your project is really creative, something that is not really actually found online a lot, like there are some stuff that is like just found online, like detecting cats and dogs. This will get a low creativity score, but if you detect something unique, then maybe you'll get a high creative score and so on. The technical difficulty of the project, is it a simple project or is it something that requires a large code base that you use stuff like classes that you make multiple files and so on? This will all count for the technical difficulty part. And then finally, the real life impact, which is how effective is the solution in a project IRL? Can this be used in real life? And does it have applications in the industry, for example? So yeah, these are the criteria that we'll be judging the submissions to the competition. And as you can see, the deadline is 16th September and 11 at 11:59 p.m. So like 2 days from now at midnight. Okay. And the prizes will be for the first place, you'll get like 150 ringgits. For the second place, 100 ringgit. For the third place, 50 ringgit. So I think this should be a nice incentive to join the competition. Yeah, try your best and do like use all the knowledge that you've gained throughout the past 5 days. And hopefully your projects will be something impressive. Any questions about the competition? Mhm. Not at the moment. Okay. If you have any other questions throughout the next 2 days, you can send to the group or send to me privately. Okay. If no other questions, I think we are done. We'll wait. Okay. The form has been sent in the meeting chat. So please fill the form for the attendance and provide your feedback.
Okay, everyone, we reached the end of this bootcamp. And as we conclude our 5 day bootcamp, I want to extend my gratitude to Engineer Anas Amir, our outstanding presenter, for generously sharing his knowledge and experience. I'm also very thankful to all of you who actively participated. I hope you enjoyed and learned from this event, and we look forward to hosting more bootcamps in the future. Lastly, I wish you all best of luck in the upcoming competition, and I hope you'll put into practice what you've learned here to succeed. Thank you all, and goodbye. And before you leave the meeting, please don't forget to fill in the attendance form. Thank you, everyone.